This podcast is brought to you by Flex 7 from TenCate Protective Fabrics. Flexible, comfortable, and powered with the strength of enforced technology. Flex 7 outer shell fabric is made to move. To learn more, visit tencatefabrics.com/Flex 7.
In the world of firefighting and public safety, reliability is key. That's why for over 2 decades, first responders nationwide have trusted the TheFireStore as their go-to source for essential equipment, apparel, and accessories. Visit TheFireStore.com online or in-store today.
For all your medication and narcotic tracking needs, check out the LogRX app, created by career fire and EMS professionals. That's LogRX.com.
Taking It to the Streets is all about advancing firefighter safety and operational integrity for the fire service. And now, the latest edition of Taking It to the Streets with your host, Christopher Naum.
Welcome to this edition of Buildings on Fire's Taking It to the Streets. I'm your host, Christopher Naum. On your street, in your city, across the country and around the world, Buildings on Fire and Taking It to the Streets is all about expanding our insights and knowledge on the built environment, its application to fireground operations, and moving forward, advancing operational excellence on today's demanding fireground. We've had the opportunity over the last couple of episodes to talk about building performance characteristics, talked about building performance indicators, and the fact that all buildings truly are predictable in the manner in which they will operate, exist day to day, and how they will certainly perform under fireground conditions. If we understand some of the parameters and aspects of what those performance indicators are going to be. We talked at length about some different applications, both in our last episode as well as in our previous episodes that are still available again in the archive sections on fireengineering.com. But going back to the fundamentals of construction, it goes far beyond just the fundamental 5 building types of construction. And we talked a little bit about the aspects of size up, some of the characteristics that define the size up, whether they are the aspects of performing the initial evaluation of the building, the initial size up of the structure upon the first due, the continuation of evolving size up both at the company and at the command level, size up considerations that any individual at any rank can be performing that add to the insights that are derived from an evolving incident. We also discussed a little bit in our previous episode some of the characteristics associated with building construction that fall under some 5 fundamental principles and 5 applications on the fireground relative to those domains. So we're going to get back into a little bit more discussion concerning some of the modern fireground considerations, especially as they fall under our first arriving construction, tactics, and safety. We continue to expand upon the conversation and the modeling of first arriving construction, tactics, and safety, the building facts model, and how that insight, again, derived from building construction, derived from predictability, building performance, derived from and correlated to era and vintage of when the buildings were constructed and built, all add to building intel and insights that can help contribute and certainly add to the abilities that we may be facing or the challenges that we may be facing, but also to expand upon our ability to be able to interface effectively and timely with any evolving fireground incident that's involving a structural fire. One of the things that we do want to make note of here, again, based upon our episode, as we move into the end of this year, our episode for this particular program is in the November timeframe. And again, that November, early December timeframe on an annual basis does give us a time for pausing to take a look at a couple of incidences, 2 of which are notable within this particular timeframe. The first being an event that occurred in Coos Bay, Oregon, that occurred on November 25th of 2002, in which 3 firefighters were killed in the line of duty during the conduct of operations in a commercial fire. That particular event really set into motion a number of different insights dealing with operational aspects, dealing with commercial structures, dealing with fireground operational and conditions and so forth. But that particular event, again, coming about here on the 22nd anniversary that marks that particular event at the Far West Truck and Auto Supply Store, gave us some interesting conversations in the fire service dealing with a number of different attributes and operational considerations. And I would encourage you to take a look at the NIOSH report from 2002 that does provide some further insights in that particular event and as relates to the operations. And again, in remembering Captain Randall Carpenter, firefighter Chuck Hanners, and firefighter Jeff Common, who lost their lives as a result of both the roof collapse and the adverse fire behavior conditions that affected that both supply store and warehouse area in Coos Bay, Oregon. Secondly, and again, I'm certain that in the upcoming weeks here, as we approach into the December timeframe, some of the insights that are going to be coming out of the anniversary of the Worcester cold storage fire that occurred on December 3rd of 1999. I can certainly remember very vividly the insights that were coming about in the early days of the internet, especially in 1999. Many of us were utilizing and expanding our ability to identify some of the things that were now coming about as a result of some new websites and new attributes that, again, both the internet and the websites that were being developed at that time were providing us. But again, on that evening of December 3rd, a 93-year-old abandoned building that was located at 266 Franklin Street in Worcester, Mass, became involved in fire based upon a variety of different origination theories. It does indicate that the fire had originated in an accidental manner somewhere between 4:30 and 5:45 p.m. on that evening as a result of two homeless individuals that had been utilizing and been frequently known to be occupying this particular multi-story cold storage building. It was actually a 6-story structure that had been previously used as a meat storage facility, had no windows. It was a windowless structure, and again, a variety of other related aspects that surrounded both the building's characteristics, its predictability of performance, coupled with the variety of environmental factors that affected that building very adversely during the course of operations that subsequently came about. I would encourage you to take a look at a number of resources. There are a number of reports, a number of books that were written on that particular event. But certainly, if you take a look and take time to revisit the NIOSH reports that came out and provide a wealth of insights on the operations and conditions that all led to 6 line of duty deaths that commonly and even to today are known as the Worcester Six. Firefighter Paul Brotherton, firefighter Timothy Jackson, firefighter Jeremy Lucy, firefighter James Lyons, firefighter James McGurk, and Lieutenant Thomas Spencer all lost their lives during the conduct of operations that subsequently occurred into the evening hours on December 3rd. 2 firefighters, Timothy Jackson, were promoted to a lieutenant, and James Lyons was promoted to a lieutenant posthumously as a result of that fire. If you've never heard about this fire, again, I do encourage you to take a look at a number of insights that are available online. We've actually talked about this event previously based upon a variety of ongoing issues dealing with abandoned or vacant structures. This continues to be a very challenging, to say the least, topic when we talk about vacant and or abandoned buildings. And again, I want to encourage you to recognize that when we talk about vacant and or abandoned or unused structures and so forth, but especially with the term vacant, that is only implying an occupancy status. It does not indicate anything at all dealing with the occupancy or building risks that are associated with a structure, both in terms of its footprint based upon its construction, predictability, the architectural aspects of the building, and other related inherent or introduced factors that may be affecting that building from a risk standpoint that certainly may influence the operations, the conduct of operations, and certainly influence our decision-making process. But again, without going into detail and making this program all about either one of those two events, I would encourage you, based upon the anniversary of both the cold storage fire from 1999 as we approach the 25th anniversary, and then also the Coos Bay, Oregon fire from November 25th of 2002, to take pause in your busy schedules, take some time to read the reports, gain some insights, and especially on Worcester, there is a tremendous amount of learnings that are coming out of that particular event even today, as a new number of generations of firefighters are revisiting that event based upon discussions. Again, as we approach the upcoming couple of weeks, I'm certain that there'll be quite a bit of additional insights, both in the online versions of publications, the various publications that are obtained in hard copy, as well as other podcasts and webcasts and multimedia programs that are going to touch upon or delve further into the topic. I think one of the topics that we will have early in our next upcoming year in 2025 is going to talk a bit more about a variety of different specific building types. In this particular instance, we're dealing with a building of both heavy timber, both type 3 and type 4 construction, predominantly type 4 when we talk about mill or semi-mill constructed buildings. But there are very specific characteristics that these buildings have, coupled with their occupancy usages, coupled with other both inherent and introduced characteristics dealing with risk factors are worthy of our conversation, dealing with what we call abandoned derelict buildings, abandoned occupied buildings, possible occupied abandoned buildings, and then abandoned maintained buildings. And again, we've developed some criteria and some insights specifically drawn from and leaning toward more heavily toward the row house type of structure and occupancy, some of the associated risks that are present with that type of fireground operations and building type. But again, I think you'll see some additional insights coming about in the not too distant future here with the publication of the NIOSH report for Baltimore City Fire that delves into the insights, lessons, and learnings and challenges that were affecting companies when operating in a building that row house building that eventually did collapse in the very early phases of operations that resulted in 3 line-of-duty deaths. So hopefully that report will capture some of the insights that we were very fortunate enough to be able to provide, dealing with some terminology, some definitions, dealing with, again, abandoned derelict structures, as well as abandoned occupied buildings or structures based upon their occupancy usage, whether it be a row house, whether it be a warehouse, or other type of related structures, certainly as they relate to this. So with that being said, let's talk a little bit more about some insights that are coming out of our conversation dealing with size of considerations and some of our predictability performance related issues. One of the things that we started discussing in our last episode dealt with size of considerations. And again, some of those relationships dealt very, very specifically with some risk considerations, some other aspects dealing with the built environment, fireground related conditions, fire service paradigms, standards of protection, resources, our operational practices, capabilities, and the variables that are drawn out from them. One of the things that we consistently look to try to connect is that there are 3 critical components when we talk about the built environment as they relate to fireground operations. And they deal with the building, the compartment, which is inclusive of fire. But again, just bear in mind that the three relationships here do have these other subsets. So it really is all about the building. It's all about the compartment and the interrelationship of the company. Three very distinct but very integrated and interrelated aspects. I seem to, and again, it's interesting to note that even this concept that originated almost 20 years ago on some of our early writings, both online and in print media, we introduced this concept of the building, the compartment, and the company, and especially as a result of additional insights that were drawn out of the early publication and insights drawn out of UL and NIST research, and then subsequently drawn out of Underwriters Laboratory research, we can see and have a greater appreciation for some of the insights that are now very, very specific to fire dynamics, of which they are all associated with the compartment. The compartment's characteristics, the very definable aspects of fire dynamics affecting the compartment, its both footprint, its volume, its square footages, its orientation, its connectivity. We've learned more about flow path, vent paths, the various types of bidirectional conditions that affect fire dynamics. Again, some of the things that were very anecdotal in the past that are now becoming very much empirical based upon these insights from each one of both past and current and subsequent research that, again, continues to connect the dots in either a consistent or sometimes in a different pattern that either supports previous insights or, again, takes that insight, compartmentizes us, and leads us down to a different path. In other words, there may not be consistency based upon these previous findings with the result of new insights and new findings, new research, these correlations that come about that either support and continue a particular thesis or correlation, or present other suggested insights and interrelationships that paint a different picture. In other words, it may either validate or those assumptions that were made provide some different insights, different variables that takes us down a different particular path. So again, when we talk about our buildings, it's important to understand the relationship of the building, the compartment, and its fire dynamics, and the relationship of the company very, very specifically from a human performance standpoint. When we talk about the building, it's about the building's predictability, performance, and its relationships to the acronym of BEAR, which I'll make mention of a little bit further. When we talk about the compartment and the fire-related conditions, the compartment is where we are drawn to, again, from an operational standpoint. It has everything to do with aggressive, postured interior firefighting operations, whether it be interior or exterior. We talk about the application of water in a variety of different variations. But again, when we talk about the compartment as it relates back to interior firefighting, it has everything to do with the compartment's characteristics, its resiliency, integrity over time, the severity, urgency, and growth of that compartment fire as it may relate back to a building or structural fire, but it has a lot to do with these two correlating elements of RIT, resiliency, integrity, and time, and the relationships of the severity, urgency, and growth, especially when we talk about that in terms of the company. And from the company standpoint, it's all about human performance regarding the knowledge, skills, and ability. It is also about the resiliency and the integrity of the individual, the team, and the company over time in terms of our operations. But it has everything to do with human performance-related aspects, error-likely conditions. But again, that leads us down into a different path. But we I think, gave quite a bit of time and energy and commitment to some theories that came about very early on, again, over 22, 23 years ago, when we started correlating human performance just from a standpoint of knowledge, skills, and ability, time-delayed actions, and how the aspect of delta time on today's fireground is so imperative when we talk about company operations, fire growth, fire intensity, and how it affects the integrity of the building from a compromise and collapse standpoint. So time also has resiliency, integrity over time, affecting severity, urgency, and growth. That has a direct relationship back to fire suppression in terms of sustainable fire flow rates and our ability to provide water as quickly and as effectively as we can, as close to the seat of the fire, but also recognizing that once we have a fire situation grow from a room and contents and get into the structure, there are very definable aspects that affect the building. It's really important to note here that, again, when we talk about some of those aspects, especially in relationship to the considerations of fire, I'll just take a moment to talk about a couple of different things. When we talk about our building performance, it revolves around 5 definable functional aspects of the building. It deals with the building's integrity. It deals with the building's construction and building anatomy. It is the building's occupancy type and occupancy risks. It deals with the third item of dealing with compromise and collapse, which are first and foremost when we talk about predictability, performance issues that affect our operations and our company deployments in, around, within, on top, or underneath that building. It's the methods and materials of construction, and then also fire dynamics that affect the compartment. And I wanted to take a moment here to talk a bit more about the fire dynamics and fire behavior as it relate back to the compartment. When we talk about methodologies and process and some of those models in terms of fire origin considerations, and especially when we talk about fire conditions, both internal or external, and especially with fires within the compartment or fires within the structure, there are 2 very definable separations of that one has to recognize, because when we talk about some of the contributors, when we talk about the dominant building considerations, there are 5 dominant aspects within the building that, as I talked about in terms of the domains, when we talk about anatomy, when we talk about occupancy, collapse, compromise, methods and materials, and the fire dynamics, the other 5 contributors to that include, again, the roof systems, floor and or ceiling systems, the compartment characteristics, perimeter walls, and then the 5th item of that is the absence or presence of voids. So it's important to note that when we talk about fires within the compartment, we're talking about the room and contents. We talk about both building and building load, as well as fire load within the compartments. And then we also, when we talk about fire within the structure, talk about fire exposure to systems, assemblies, and especially when we discuss those aspects as they relate back to what we consider to be the 5th very critical aspect of voids. It's, again, concealed spaces and the characteristics of the voids. Are they inherent? Are they introduced? What's the size in terms of volume, square footages as they relate to them? And how do they relate? A very common aspect when we talk about concealed spaces within the aspects of a roof assembly and the exposure of both components, systems, and assemblies. We should be very knowledgeable of mass to surface ratios and how they may affect structural integrity. So hopefully, again, you're seeing that this all has a very interconnected and interdependent relationship here when we talk about first derive and construction tactics and safety, severity, urgency, and growth. But I did want us to take a moment here to reiterate some things that we talked briefly about in terms of our size up in our previous episode, and that deals with fire origins when we talk about compartment and or structure. So there are aspects dealing with the compartment to structure. There are considerations of the structure to compartment, external to compartment, external to structure, and how they all have very specific, both strategic and tactical considerations. With that being said, I'll also expand upon this again to reinforce the concepts, is that we have both fires within the structure, fires within the compartment, and there's going to be some considerations of dealing with compartment to structure. It is structure to compartment. It is compartment to compartment, compartment to external. It is compartment to external to structure. It's compartment to external to structure, external to compartment, external to structure, external to the compartment to the structure, and then compartment to structure. So they all have very, very specific characteristics that, again, relate back to upon arrival. And again, during the process of size up, one has to identify how they may be identifiable, number one, and then how those insights through observations are going to lend to the communication process back to command that is going to hopefully have some consideration in the decision-making process. But each one of those, when we talk about them, again, are very important to recognize, comprehend, and to internalize, both in terms of size up considerations, as well as both the building reads, both reading the building, reading the compartment, reading the fire ground, and then how that relates back to overall operations. One of the other aspects here when we talk about the adaptive fire ground related back to the influence of the building environment, incident severity, urgency, and growth that relate back to operational considerations of fire dynamics, and then the availability and the composition of personnel in terms of staffing levels when we talk about HU. Again, just recognize that human performance and staffing and resourcing is going to affect risk potential on the fire ground as it relates to the human performance capacities in those characteristics, and are going to be variables. They're going to have a variable when we talk about that from a time-dependent standpoint. One of the other things that when we talked about the considerations, and one of the things I wanted to really focus in upon here is about some considerations dealing with the building, both in terms of the anatomy and, more importantly, just expand a little bit further on era and vintage. But I did want to spend a little bit of time here on our episode talking a little bit about the evolution and the changes over time, especially as it related back to some of the code provisions. Now, when we talk about building codes, we certainly should be aware at this point in time that there is a standard code that across the United States. It's the International Building Code and the International Fire Code. The current editions, whether you're operating under the 2021 or the most recently adopted 2024 version of that code, but for many of you, either the 2018 or 2021 code, there are some very specific insights that are drawn out of that, especially when we talk about occupancy classifications and usages, hazards and risks, whether those risks are low, moderate, or high. There's some other additional insights, but if you're not familiar with some of the details and have not had the opportunity to read into the extensiveness of any one of those codes, especially with the 2021 International Building Code, one resource that I would highly encourage you to take a look at, I'm just drawing that back into the forefront here, but I would encourage you to take a look at a couple of different resources, and actually one of those resources that I'm going to make mention of here, and I'm not going to be able to bring it up on the screen, but I'll make reference to a couple of different books here, and both of these are written by Francis D.K. Ching, or Francis Ching, C-H-I-N-G. One of them, especially when we talk about gaining some more insights on building codes, one of the books that I cannot speak more highly enough about is the Building Codes Illustrated book. It's a guide to understanding the 2021 International Building Code. It's the 7th edition. Francis Ching was the author, along with it was co-written by Stephen Winkle, who is a registered architect, a fellow of the American Institute of Architects, and a professional engineer. But Francis Ching's very illustrious illustrations, coupled with some very easy to comprehend reads on understanding building codes from an illustrated standpoint, is a very worthwhile book to obtain and book to get onto your reference library. That comes in addition to Francis Ching's Building Construction Illustrated, and again, both the 5th and 6th editions. I'm just going back to my notes here. I think that I made a quick note somewhere here that, so I'll go back on recall. So Francis Ching's Building Construction Illustrated, the most current edition is the 6th edition. Again, you can find these editions and other previous editions going all the way back to the 1975 first edition that I do have sitting on my professional library shelf. It was a book that I obtained in my second semester in college when I was going and working toward my baccalaureate degree in architecture at Syracuse University. Again, our second semester there back in 1976, we obtained and were instructed to obtain one of a defining books that gave me a wealth of insights, but that was the first edition of Francis Ching's Building Construction Illustrated. So again, the most current available edition is the 6th edition on Amazon.com. Again, you can buy all of the previous editions. The earlier editions, both the 3rd, 4th, and 5th editions are sometimes as cheap as $5 to $6 to $10 a copy. The more current editions, especially with the 5th and 6th editions, you can look to be paying somewhere upwards of $30 or so for it. But I will give you some advance notice here. The 7th edition of Building Construction Illustrated, which again is going to have a wealth of additional insights on a variety of expanding architectural and building material evolving concepts and usages. That 7th edition is currently scheduled for publication in February of 2025. So I certainly am very much looking forward to that edition coming out. And I would encourage you, if you've never heard about any one of those two books, I would encourage you to pick up, again, Francis Ching's Building Construction Illustrated, any one of the previous editions from number 6 or 5 or 4, as well as some of the more earliest editions, again, just to have some insights on some technology and material information. We talk about methods and materials of construction going all the way back to 1975, almost 50 years ago, that I first was exposed to some of that insight and information when I was studying to become an architect back in that particular era. Two other books that I'll make reference of, again, since we are talking about some referencing insights, and those include The American Home by Lester Walker and The Field Guide to American Houses by Virginia Savage McAllister. Again, two additional books along with Building Construction Illustrated. And since we're talking about some other referencing, and I also want to encourage you to take a look at the 2021 edition of the NFPA guide, the 1700 guide to structural firefighting. That's all based upon some insights derived from insights, learnings, and research from both UL's various studies and so forth. But again, if you've never heard of this particular guide, it's not a standard, it is a guide, but the NFPA 1700 guide is a very useful document that'll provide some insights for you. So with that being said, we started a little bit of our discussion here. We've sort of been going round and round on a couple of different aspects here through our thread of conversation. Our acronym of BEAR deals with, again, building, era and vintage, anatomy, and risks. And again, we talk about the basis of predictability of performance. It is both inherent as well as introduced. It's intrinsic, it's adaptive, it's new. All of these things are defined by our codes and standards. So it's not something that is going to go away, but it has its basis on the building's predictability in terms of what standards or ordinances or laws that were enacted at a particular time that revolve around the era and vintage. And again, when we first introduced era and vintage considerations, going back almost actually about 25 years, late 1990s, when we first identified and correlated, and again, the rationale behind this that no one else who's utilizing this term or has come to introduce the term in their conversation and discussions. There has been a book that's been written about reading the building, discussing era and vintage, but our genesis and being the originators of that concept were all derived from architectural and engineering. It is defined by decades and or periods of construction. Its direct relationship to our insights of architectural engineering practices and the relationship back to our basis and our thesis of predictability of building performance. They all have very defining characteristics. They are all related back to, first and foremost, the building's anatomy that relates back to the other five fundamentals. So again, just to give you some insights of what that basis was, when buildings were being developed and constructed in these different era or periods of time, They were all being derived from the development and insights from additional research, ensuing new methods and materials of construction that were being introduced. So we had new introduction of methods and materials of construction that all, again, relate back to different levels of occupancy usages and risks that had different levels of fire dynamics affecting the building. I'll just utilize the example of the introduction of balloon framing. Balloon frame construction as a part of a building anatomy in a residential constructed building introduce characteristics that, again, when we talk about the inherent voids that are present in that structure that allow for fire communication and travel and propagation, both within the structural anatomy, within these concealed spaces, are inherent. So again, that was very common in that particular era of time in the late and early 1900s. That gave us a particular building type, balloon type framing, that all ended up giving us a very predictable type of building characteristics. But I do want to take a moment here, and again, just to talk a little bit about some aspects of our codes and standards and how those aspects of the evolution over time, especially when we talk about the introduction of some very specific codes and ordinances back in the 1860 era of time all the way to current, the 2024 era. But a couple of different things here when we talk about the relationships go back to considerations of the NFPA 220 standard, both the International Building Code and the International Fire Code, under the auspices of the International Code Council, and how all of these, again, and especially when we talk about the early influences of both building and fire protection, life safety codes and standards, and especially the development of the National Board of Fire Underwriters and the National Building Code that all came about in the late 1800s and the early 1900s, very specifically in the 1900 timeframe. In the year 1900, on that 15-year period from 1900 through 1915, were very defining. But when we saw some of the introduction of the earliest codes, especially coming out of the Civil War era, the 1867 Tenement Housing Act and the 1871 Chicago Fire were two very defining periods of time in which codes and ordinances or acts, as we made reference of, the Tenement Housing Act, were coming about as a result of unchecked construction and growth of the built environment, the occupancy risks that were associated with very significant risks in these particular types of structures, the tenement buildings in particular, with the unchecked construction that was taking place predominantly in New York City, but affecting a variety of different areas, whether we talk about Boston, Philadelphia, but especially in the tri-state New York, Connecticut, New Jersey areas, the implications of both quality of life as well as fire life safety affecting these buildings and the types of fires and the conflagrations that were occurring through these developing metropolitan areas in that mid-post-Civil War era of time all came about to give us these particular standards. But very quickly, I'll give you a quick rundown, just some insights from some benchmarks that are very critical. So we talk about 1867, the Tenement Housing Act. The Chicago Fire was very defining, especially when we talk about fire zones and fire areas that came into place as a result of the significant conflagration of the Chicago Fire. The Old Law Tenement Act that was instituted in 1879 that, again, changed some things dealing with the 1867 Tenement Act. So these are very, very important to recognize. There were three very distinctive acts that were code-related that came about that started really influencing a variety of other structures, not just the tenement buildings, but a variety of other aspects that had implications on reading the fire ground in terms of the positioning, the types of orientation, and considerations of how a building was sited on a particular lot or piece of property. They affected both the square footages, the volume, and the height factors that get back into some code-related issues. But the Tenement Housing Act of 1867, coupled with the Old Law Tenement Act that was called that due to the New Law Tenement Act. So we had a act in 1867 that established some very specific criteria on both life safety and building construction related conditions. An amendment to that act occurred in 1879, and that was in effect from 1879 to 1901. And in 1901, a third revision to the Tenement Act came about that changed other related conditions, and that act was in place from 1901 to 1929. So after that third revision came about, they changed the titling, and our current referencing to those tenement acts are as follows. So when we talk about the original Tenement Act for buildings, construction, and life safety, that was the Tenement Act of 1867. The enactment of the revised Tenement Act in 1879 is now referred to as Old Law Tenement Act. So we have old law buildings, and again, this is very important when we talk about some of our metropolitan areas and the tri-state area of New York, New Jersey, Connecticut, Boston, Philadelphia, Baltimore, and even all the way down to D.C. There was the Old Law Tenement Act, in which certain buildings from 1879 to 1901 were constructed that had very specific characteristics in terms of their configuration, their footprint, the types of windows, the orientation of stairs, even to the degree or the absence of fireproofing, the orientation of rooms, and their ability to join or be separated, aspects of stairwells, protection levels, dead man rooms, and so on and so forth. The New Law Tenement Act, which was instituted in 1901, gave us that separation. So the Tenement Act, original Tenement Act, 1867, Old Law Tenement Act, and the types of construction in buildings from 1879 to around 1901, 1902, and then the New Law Tenement Act of 1901 that, again, was in place from 1901 to 1929. I'll make reference to, again, when I talked about the National Building Code, the National Building Code that was issued by the National Board of Fire Underwriters that had existed in the late 1800s. The first National Building Code, revision number 1, was issued in 1905. It was being developed in 1901, and again, 1901 through 1915. By the time we reached that 15-year period of 1915, the considerations for building construction, methods, materials, collapse and compromise, occupancy considerations, building anatomy, the footprint, the fire protectiveness of them, and the manner in which fire dynamics affected those buildings were starting to become very recognizable. And again, if you want to understand how Main Street buildings were built, they all have to do with these insights derived from these particular acts in what we can refer to as codes. But especially with the National Building Code, the earliest editions, as well as the first edition of the National Building Code for mid-size cities or smaller size cities. This had a tremendous degree of impact on construction, as well as how buildings were constructed, how they were improved. More importantly, as we talk about them here in 2024, how they react and how their predictability, if we understand what went into these buildings, especially over these era of time. Very quickly, a couple of other insights. The San Francisco earthquake that really established fire zones in fire areas that came on the heels of the Chicago fire from 1871. But in 1906, the San Francisco earthquake started really giving us a tremendous degree of insights. The National Board of Fire Underwriters, the National Building Code, firmly became established in 1915. The Uniform Building Code that predominantly affected the West and Southwest was issued in 1922. The first seismic regulations came about in 1927. And then in 1929, the New York State Multiple Dwelling Act came about, and that changed. Again, that dramatically changed everything dealing with multiple occupancies. Although rooted here in New York, it subsequently became adopted across the United States dealing with multiple dwellings, and that replaced the new Law Tenement Act from 1901 that existed from 1901 through 1929. The Long Beach earthquake in 1933 was another significant event that brought into consideration and into the forefront the issues dealing with unreinforced masonry construction. We talk about ordinary type 3 construction, but again, recognize that type 3 did not exist by virtue of title in that particular era of time. So although we talk about 1933, we talk about the Long Beach earthquake, we talk about type 3 brick and joist construction, type 3 as a reference type of construction did not exist back then, and just bear that in mind. And I'll make reference of why that changed. So based upon the 1933 earthquake, in 1935, the Field Act came about in California, and it was also, the Field Act was associated with schools, predominantly educational institutions, and then the Riley Act dealing with all buildings came about, originated in California, dealing with not having any more unreinforced masonry construction, and little by little that all became instituted in both the New York State Building Code, the Southern Building Code that came about in 1945, the Uniform Building Code from 1922, and then ultimately all of the BOCA Code, the Uniform Building Code, the Southern Building Code. These all became integrated into the International Building Code in the mid-1990s, and then became known as what we currently have, the the International Building Code, International Fire Codes that, again, were promulgated in the late 1990s and then the early 2000 era of time, which goes back to this whole issue about building classifications. So we make reference, and many of us are familiar with the typing of buildings, and that's all associated with building construction features that are predominant to building integrity. So we have types 1 through 5, Roman numeral 1 through Roman numeral 5, or the V, or type 1, type 2, 3, 4, and 5. But they all relate back to fire resistiveness characteristics of the building that affect both building integrity and occupancy usages. So we type 1, fire resistive, type 2, non-combustible, type 3, ordinary, type 4, heavy timber, and then type 5, wood construction. So many times I'll hear individuals as I'm lecturing around the U.S., when I ask, well, what's type 5 construction, they'll say it's lightweight construction. And that's, an inaccurate statement, because it deals with wood framing as a building anatomy system, but it can be inclusive of everything from braced framing to balloon framing type construction to conventional wood framing systems, to as well as lightweight engineered structural components that are part of the wood framing system. So recognize that. I'll further add here, as we talk about typing and classifications of building anatomy, is that the NFPA 220 standard, I made reference to that a moment ago. The NFPA 220 standard was first drafted in 1952 and first issued in 1954. So 70 plus years, 16 editions, and they all, again, give us our type classifications of construction systems, building integrity, predictability, performance that did not exist prior to 1954. So prior to that, buildings were classified as follows. So in 1905, with the introduction of the National Board of Fire Underwriters, the National Building Code, there were only 3 types of classifications at that time. And they included type 1, which was frame construction, type 2, which was non-fireproof construction, of which there were 2 subsets. There was ordinary construction, as it related to type 2 alpha, ordinary construction, brick and joist, and then there was type 2 Bravo, which was mill construction. So distinctively in that 1900 era, 1901, 1905 in specifics, to around 1915, we saw this typing of construction that was very, very specific. And then the third type was type 3, which dealt with characteristics of fireproofing construction. And that fireproofing all came about as a result of the conflagrations throughout the mid 1800s to the late 1800s, conflagration, the introduction of life safety considerations to civilians due to predominant large loss fires in a variety of different occupancies that led to large catastrophic loss of life of civilians and workers in these particular structures, and the need to provide additional fireproofing characteristics to our buildings. So it's important to note that, again, our buildings in the late 1800s, early 1900s predominantly had these characteristics revolving around three specific types. Type 1, frame construction. Type 2, dealing with non-fireproof construction, of which we had 2 alpha, ordinary construction, 2 bravo, mill construction, and then the third classification of fireproof construction. Some things started changing in that 1929, 1930s era. There were some additional classifications, especially out of New York, that started influencing other construction throughout the United States. I'll just make reference to these characteristics. There was characteristics dealing with legacy building construction in the 1930s. There was Class 1 through Class 6, which dealt with Class 1 was a fireproof structure. Class 2 was fire protected. Class 3 was non-fireproof. Class 4 was wood frame. Class 5 was metal structures. Class 6 was heavy timber. So even as a result of, again, this was all introduced as a result of changing methods and materials that all had everything to do with era of construction. So you can see this correlation of how we started connecting these considerations when we came up with these different eras. So era and vintage goes well beyond just talking about modern construction and legacy construction. And again, I can't stress enough about how inaccurate utilizing the term legacy construction is to the fire service, to our fire ground operations. And unfortunately, when it was introduced as a result of its characteristics and trying to define, correlate some differences between modern construction and older buildings or older methods and materials of construction, it has done a major disservice to the American Fire Service when we talk about it in terms of two very distinctive periods. And we can't. When we talk about modern construction, there are subsets associated with that we'll talk about in another upcoming episode. But there's also this characteristic of legacy construction, of which the term legacy has absolutely no bearing, because legacy construction has subsets that are associated with these different periods and eras of construction that all are directly related to the construction features of that building, the methods and materials of construction went into them, occupancy types and risks, code classifications dealing with, or characteristics dealing with predictability performance of the building related to collapse and compromise and fire dynamics. So I can't stress that enough. We'll delve into that further in an upcoming episode. So there was a subset that in the 1990s related back to combustible and non-combustible construction. And again, it dealt with groupings. Group 1 was non-combustible. That was associated with, again, fire characteristics. Group 1, non-combustible, related back to 1 alpha, 4-hour ratings, 1 bravo, 3-hour ratings, 1 Charlie, 2-hour ratings, and 1 delta with 1-hour ratings, and 1 echo or 1E, which was unprotected. So that was, again, groups 1 of non-combustible construction. Buildings of group 2 were combustible construction. 2 alpha was heavy timber. 2 bravo, protected wood joists. 2 Charlie, unprotected wood joists. 2 delta, protected wood frame. And 2 echo, unprotected wood frame. So just recognize that there was these characteristics and considerations that really changed a lot of things. So it's not just once and done when we talk about the 5 fundamental building types, and even to the standpoint of building classifications. If we were to look at the types of classifications that the 2021 International Building Code and Fire Code give us, they certainly were different than code classifications that the National Building Code gave us in 1905, or in that era of the late 1800s, early 1900s, all the way up through until we started standardizing these in the 1950s. So again, over 70 plus years ago, 74 years ago, we had some different characteristics, different classifications. So I'll give you a couple of quick notes here on a quick read here. When we talk about the National Building Code, this was 1 through classification 11. There was 11 different classifications at that period of time. Private dwellings, apartment houses, tenement houses, lodging, hotel, office, public buildings, theater and places of amusement, warehouses, manufacturing, and factories. Additional enhancements in the 1915 through 1919 National Building Code and the National Board of Fire Underwriters provided 3 classifications, and they were both Class 1, Type 1 was buildings of public buildings. Type 2 were residency buildings. Type 3 were buildings that were associated with businesses. And in each one of those, there was a different class. So public buildings, Type 1, they were buildings that had both Class A and Class B. Residency buildings of Type 2, Class C and Class D. And then buildings of business occupancies and risks were Class E and Class F. So we can start seeing that there's all of these subsets that all came about in these different building codes and classifications that were all era-driven considerations. And then lastly, I'll just make a point saying that when we talk about some of these considerations, we have to recognize that there are different periods in which, very significant periods in which there's this evolution of change, both in terms of buildings and occupancy classifications, as well as some of the characteristics of risk. And I'll just point out a couple of them here in our conversation. Some of these major periods occurred, again, in the early 1900s, specifically as a result of changing buildings and materials. So this whole era of the 1900s through about 1940, 1940s, or post-World War II era were very, very significant. But a couple of different things here to make of note. 1920s, the introduction of electricity. So one of the first changes was the introduction of gas services and modernization into buildings in the late 1880s, early 1890s. So that was very significant. The introduction of gas service into buildings started modifying and changing the renovation and implications of our buildings. The introduction of electricity, the standardization in the early to mid 1920s. The 1930s, the post-Depression era, saw a major change in building renovation issues that are affecting what we call building life cycles. The post-World War II era and starting the modernization into the 1950s was another significant period. So coming out of World War II, we saw the modernization era coming about that started changing the internal aspects of our buildings, that started creating additional voids, started changing considerations of layout, configuration, stairwells, room sizes, and so forth. The late 1950s also saw a significant era of modernization coming on the heels of the mid-1960s, where we saw both the urban decay and the modernization of decaying cities, but a major significant influx in building construction and modernization occurred with the space era of the mid to late 1960s. In the early 1970s, 1973 through 1976, the energy crisis had a major influence on changing configurations and modernization of our buildings. The additional 1970s and in the early 1980s, again, another period of urban decay and urban renewal. And then the conservation efforts that occurred in the mid-1990s, and then all the way to the efforts in the 2010, all the way to today, where we see adaptive reuse of our buildings and how those all are having some significant contributors toward the modernization and those levels of risks in our buildings. One of the things that I wanted to talk a little bit further about were some characteristics and some common themes dealing with the influence of decision-making and operations, predominantly dealing with building behavior, predictability, performance, resilience, integrity, and time, that revolve around some of the things that we just talked about, especially dealing with occupancy loads, structural loads, environmental loads, seismic loads, fire loads from the buildings and compartment fire loads dealing with fire load packages. But I think that we're going to leave that for another upcoming episode when we talk about some of those related aspects. And again, how we have some continuing themes with the lack of benchmarking, pattern recognition, the lack of recognition, prime decision making, or naturalistic decision making that revolves back around experience, critical thinking, the lack of decisiveness on decision making, risk management, and some of the considerations back on time. But I think we'll leave that for another discussion in terms of a conversation piece for an upcoming episode, probably leading back into 2025. One of the things that we are trying to correlate here, again, that fundamentally revolves around our conversation in our previous episode, dealing with the foundation of the cognitive processes of that first do of thinking, knowing, remembering, judging, and problem solving. But again, the most critical when we talk about them is knowing and remembering that really go under, again, critical thinking. And those, again, go back to, again, working memory, category formation, and pattern recognition. So we're going to talk a little bit more about those in our upcoming episode in 2025 and expand upon some further conversations on the first arriving construction tactics and safety. And I think we'll also maybe correlate back that to some further conversations on some correlations between residential and commercial. We've got a couple of upcoming programs in 2025 nationally that will be connecting that doc about decision making. We'll talk a little bit further about that, I think, at that particular point in time. So with that being said, again, we've talked about a number of different items here on this particular episode of Buildings on Fire, taking it to the streets, and again, building upon the last two episodes or series dealing with predictability performance, some of our performance indicators, and then our last episode dealing with fireground size up. I gave you some insights on two very highly recommended books dealing with Francis Ching's Building Construction Illustrated, and then also Building Codes Illustrated, both again from Francis Ching, that I would encourage you to take a look at. So again, we've had an opportunity to talk a little bit here over the course of our last 60 quick minutes, but again, it's all about continuing that conversation. So we do have one more episode that will be coming up in the month of December that I think we're going to correlate and back and talk about some lessons and learnings from the fireground. The month of December, again, is a very critical month that has a lot of lessons and learnings that are rooted out of the hard lessons of learnings from a number of previous events that we will talk about. So again, I want to thank you for taking time to listen on this episode of Buildings on Fire, taking it to the streets. So until next time, companies are in quarters and off the air. Stay safe, but keep in mind there's a job being worked somewhere in the streets in your city, across the country and around the world, doing what we do best and being who we are, and that's firefighters. So take care. Thanks for listening in on this edition of Buildings on Fire, taking the streets. I'm your host, Christopher Naum, and until next time, stay safe, and again, keep learning about the built environment. So thank you very, very much for taking time out of your schedule. Thanks again. Stay safe, and happy Thanksgiving to everyone.
This podcast is brought to you by Flex 7 from TenCate Protective Fabrics. Flexible, comfortable, and powered with the strength of enforced technology. Flex 7 outer shell fabric is made to move. To learn more, visit tencatefabrics.com/Flex 7.
In the world of firefighting and public safety, reliability is key. That's why for over 2 decades, first responders nationwide have trusted TheFireStore as their go-to source for essential equipment, apparel, and accessories. Visit TheFireStore.com online or in-store today.
For all your medication and narcotic tracking needs, check out the LogRX app, created by career fire and EMS professionals. That's LogRX.com.